Okay, so when doing the 5-layer tetrahedron, bear in mind that we already actually did a 5-layer. We did that in a derivative way with the 4-layer. The 4-layer is just a derivation of the 5-layer with hidden centers. The issues that we ran into with parity and whatnot, that's going to be taken away because now we have a center. And it's solved exactly the same way. So let's go ahead and scramble this up. And we're going to go through the process of reduction. So let's get a good scramble here. Okay, can't make it too easy. Now you're going to find a lot of similarities with the Pyraminx, the master Pyraminx solves, but not exactly, because this is going to be reduced down to a Jinx Pyraminx, and I do have a video where I solve it as Jinx Pyraminx, or reduce it to a Jinx Pyraminx. Okay, are we good? Yeah, we're good. Alright, so the first step, and actually we'll go ahead and scramble this. Now we are from time to time going to be using some algorithms, and that will be the same algorithms that we did with this guy over here, and that's rotating these pieces here, or rotating these over here. So as you recall, to rotate these pieces, these edges, which are really represent these edges here, it's going to be down, 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 up, slice this up, and down, up, up. Okay, so this went to here, this went to here, and this went to here. It messed up some of these, but we don't really care about that yet. Speaking of these, to move this to here, and this to here, actually let's find one where the pieces are. Okay, this to here, this to here, this to here. It's going to be up, down, down, up, down, down, up, up, and that did 3 cycle these. Now remember, we did a whole lot of repositioning, positioning, and repositioning because we had a whole lot of these that had to be placed like that. And it took a little while, but we're going to do a different kind of a solve, which only utilizes those algorithms once, maybe twice, but the rest is all just reduction. Reducing this to a Skewb as we reduced it to a tetrahedron. 3-layer tetrahedron. Wow. Okay, good. So that's what they both look like scrambled. So first thing to do is we do center reduction, but now I don't have to guess where it is. I don't even have to use the corners because I've got the centers to guide me. So I'm going to first put this portion of the center of a green one in. Boom. Now what I'm going to do is I'm going to line a green center here with a green corner center over here. So let's see if we can move that in from here. This is already in. And just move it in. Whoop. Turn this over here and we move this in over here. Bang. Now I'm going to get all of these in. This is already in, but we don't really want to move this in as of yet. So I'm going to move this in to match up with this edge, or the center. This I'm going to line up. And I want this to move into here, so let's move this to the side. And I've now assembled this piece over here, turn it to the side, move it in, and just like that, we have the green center. Now, I know where all the centers are supposed to be. Here's a blue one. This is already in. And if I move it from this perspective, I won't take the green center out. So let's get a blue, move these two in. So there's another blue edge right here. Let's move it in like this, move it down. Now I can move it up like so. Now I've got this whole side to get. Okay, I'm going to move this in. And this one needs to be moved in, so move this down, whoop, across here, move this in like so, turn, and move it in. Okay, these two are in. We just have 2 more to reduce. And that's these. I don't have to guess which one it is. So now I have to coordinate these centers here. So how do I do that? Well, what I could do is take this out. Take this out like so. Move it to the side and move this down. Okay, now it's not too difficult. I'm not going to give you algorithms on moving these. They certainly exist, but I think you can try to intuitively place these. So these centers are now in. So now we're going to do edge reduction, and it's the same way that we did with these other puzzles. So we find, here's a blue and green. Here's a blue and green over there. So this needs to move into this position. So I can do that by moving this across here and moving this up. So this is going to move into here, batting out the green and the red. Find the green and the red right over here. But I need to move this. Oh, I'm looking for the red and blue edge here, middle edge. I don't see it there. It's actually here. Now the problem is that this red and blue is attached to this, so it doesn't matter what I put here. So it's going to be down, 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 up, up. This will move the centers back and move this back in. Okay, so this is the edge that I put in right over here, blue and green. We'll find the other blue and green, which is here. Okay, I need to move this in to this configuration. This will come into here. It'll knock out the yellow and green. Find the yellow and green here. I can't find it there. And it turns out it's this one, so I can't use it anyway. So we'll use this as a sacrificial lamb. Move this in, down, down, up, up. Move this up. Okay, so this is fully reduced. So now we can put this one in. I've already got this in place. This is the blue and yellow. Find the blue and yellow, which is right here. Now when this moves up, the blue is going to be on the bottom here. It's going to be facing us, so is this when this moves up. So we'll move this in to reduce this side. Then with this one, we go down, down, up, up, move it back, and this is in place. Here's the other one. This has to move to here. So we'll place it, move this into here to line up with the red and green. And here's a red and green, but it's upside down. This red is here. This, I want the red to be facing this area here. So let's move this across and down, and now this is where it needs to be. So down, 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 up, up, and up. Okay, so now we have our choice. Let's start to assemble these guys here. This is the wrong blue and red. So I'm going to move this into this spot here, so this can fold into here. This is where it's supposed to be on the other side, so I can't use any of those. These are all in. So in actuality, well, no, there's one more. There's this. Okay. So I move it in this position, so this will be moved into this. Whoops. This will be moved into this position here. So move it in to properly reduce this, then go down, down, up, up, and move it back. So what I should have is I should have 3 with 1 out, and I do. So I want to put the green and red. Here's a green and red here. I have to move it to here. So let's move it down across here. Move this up to here. Now I can move this back up and across. Okay, so this will move into here to match with this guy over here. Now I need to move this upside down so that this can come into this spot, and if this is upside down, this will end up over here. So the way to turn it upside down is move it to the side and then move it across. So I did just basically a D and a R, 2R. Okay, so this is where it needs to be. This is moved down, 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 up, up, and move it back, and that's reduced. So we're seeing a purely non-parity version of the puzzle. And you saw how much faster I was able to do that. So now we just proceed with our method. So here's green and red. Let's put the other green and red here. And that is right here. So this will move in. This is already in position. So our first side is done. Here's a green and yellow. So move this down, across, in, and up. So this is good over here. Here's a green and red. It has a nice home over here, down, across. across and up. And finally this, but it's upside down. Let's move it out. And then we move this down, across, and up. Okay, so it turns out this center is already in. And as I look at this, well, that was really easy because all these centers were in. Could have been harder. Could have looked a little something like this. Well, actually, it doesn't matter. These centers are in now, but they're not going to stay that way. So we take a look here and we see that these are upside down. So either they're going to be all off, or they're going to be all in, or two are going to be in but upside down. So that's a familiar situation. When you see that, just take any one, go down, down, up, up. And right next to the one that was in place, this is going to come down to here. So turn it over here and go down, down, up, up. All the corners are in, and now we just have to swap these centers. These two centers and these two centers. Now notice there was no parity with this. Everything went exactly where it was supposed to be because we knew exactly where it had to go. So we're going to go 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, and 3, and done, solved. So you can see that that was probably as straightforward to solve as this guy over here. So now what about the master Skewb? What if we solve this exactly the way that we did this? Now what we're going to do, unlike what we saw with F-Skewb, we have to predefine what our corners are going to be and what our centers are going to be. Because there's equivalency in how this puzzle looks. Because this turn, in terms of the number of pieces and the function of the pieces, is equivalent to this. The difference is that there's equivalency regarding the color and the shape, and every one of these pieces are different. So we just have to keep in mind what we're defining as what. So let's take a look at, let's start off with the green. And let's say that I'm going to define this as a corner. So I'll define this as a corner. So corner, corner. Let's define the other green as a corner here too. So I'm going to match these two together. So these are going to be corners and these are going to be centers. And if I match the white one here, this is going to be my side. Here, here, and here. So if you can imagine a triangle with these two corners and this corner, that's what these are going to be. Which means that this is going to be a center. Now I don't have to figure out, put all the corners in and decide what center goes where. I already have these centers here. So these centers are telling me already what's supposed to go where. So that's what I'm going to do. Now that I see what's what, once I put this in, I'll be able to figure out what this is. All right, so so basically this is in. What I'm looking for is I'm looking for a so I'm going to start putting these guys in here. This is going to be a green with a green and yellow. So where's the green and yellow? And a green and orange. So I'm going to find those. Here's a green and orange, and this has a green with it. Is that the right piece? We just basically turn this until we can move this in where we want it to go. So let's move this across here and move this in. Bang. So you see this is correct. Just like this. So this is correct, but I want to put the green and yellow in here, and alternatively I can move this out and just put an orange one in here. So actually I'm going to move this here, turn this across, move this up. So here's my orange. I'm going to move this over to here, and I'm going to move this in. So basically now I have all of these. I just have to move all of this in over here. Let's move this out so I can more easily bring this into position. We're going to move this. Okay. Move this guy over here. Move this up. So this is in. Now what I want to do is I want to find the green and yellow, which is right over here. So let's move this out. Turn this where I want it, move it back. Move this in, and now we have our first center. Okay, so this center was placed. Now where do the other centers go? Well, it's going to be kitty corner to this. So here's the other green, and that's where it's going to be. So let's put this in. I'm going to move this in this direction here. So anything I move here won't take this out. So what I'm looking for is I'm looking for the white and the green and white. Well, here's the green and white over here. So I just want to move a white one in. A white one into here. So I think if I move this out over here, bat this out of the way. I actually want to move a white one in here. So bat this out of the way. Here's a white that I can move. Okay, I'm going to move a white one to here. Get this out of the way. Move this over here. This green and white can now match with this white, and boom, so this is here. Now that I've got that, I'm going to move this into here. So these are in. This is also in, but that's not really what I wanted to do. I want to match a green, a red, and white with a red over here. Okay, so I need to get a red one here. So if I move this to here, move this to here, I'm going to get that out of the way. I've got a red one here. Move the red one to the side. Move this back. And now I've got this matched with the red one. I can see that this one has to participate as well. So if I move this to here, I want to get this green and red to match up with this. So let's move this out of the way here. Move this again. And I'm going to turn this green and red so that this can match up with this red over here. It's turned over here, matched up. Turn it across, move it in, and now this is done. Now I know I moved kind of fast. You can slow down if you need to, but basically I'm very intuitively notice without any algorithms placing it. Just learn how to move this puzzle around. So you can see these two centers are in. The other two centers are going to be this one, and each of the piece is in these centers. So all the components are here. So what's supposed to go where? Well, I can just look at the centers here. My suggestion is to put these guys in. Yeah, is to put these guys in. So I see this red one is in here. Let's turn this. Now, anytime I make a middle move, I'm gonna offset the center, so I've got to move a middle move back. And what I'm going to do is I'm actually going to use the algorithm that we showed of how to move these centers, these edges along. So what needs to go where? This is a red and blue. A red and yellow. This needs to go here. So let's turn this over to here. This will go here, which is good. Where do you need to go? Well, this needs to go, well, basically needs to go here, but I can't get it there yet. So let's move this in first. So we've got down, 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 up, then up, and down, up, up. Okay, you can see this is where it needs to be, and none of the rest are in, so I'm going to move this like so. This red and white and orange rather, this needs to go here, so I'm going to move this up to here. So this will go here, this will go here, and this will go here. So move at least one of these in. So it's down, 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 up, and up, down, up, up. So now this is in. So now we really should just have a 3 cycle here. If I move this like so, and move this here, this will go here, this will go here, and this will go here. If I move it 3 times, yeah, if I do it twice, this will go 1, 2, be where it needs to be. This will go 1, 2, be where it needs to be. 1, 2, be where it needs to be. So down, 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 up, and up, down, up, up. Do it again. Down, 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 up, and up, down, up, up. Okay, so all these are in, and these are in. Now remember, in the last one I had to do that an endless number of times by doing deconstruction and reconstruction. When I just have it down to these two centers, that algorithm, you only need to do it maybe 3 times, 4 times at the most, probably more like 3 times, and you're really just dealing with these two centers here. It just makes it really easy, and all I have to do is move these around. So there's not any of that deconstruction. Now that I've done that, same kind of process, I can move these in, and that shouldn't be too hard. Move this to here. I want to move this. If I do it twice, this white one will be in here. Well, actually, if I do it once, I'll move this orange one in here. So that'll be okay. So down, 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 up, up, down, up, up. Okay, so this is in. Let's move these into positions that we could use. This will go here, which is good. This will go here, and this will go here. So that'll move all but one in. So up, down, down, up, down, down, up, up. Okay, so I've got 2 to go. I'm going to move this over here. And what I want to do is move this red to here, and this blue to here, and this blue to here. So, final algorithm, up, down, down, up, down, down, up, up. So all these are in. Luckily, that's the last time you needed to use those algorithms. No more deconstruction or reconstruction. Just complete freedom to turn this wherever you needed it. The only compromise is you had to position these centers, and that was pretty easy. You don't need any algorithms. You just need to sort of intuitively move it in. It might take a little bit of practice, but I kind of enjoy not having to do all that turning of the puzzle around to keep doing those 3 cycles all around the puzzle after placing these guys in. Okay, now that we've done that, we're going to treat these as edges. So just like with this, we do edge reduction, and we do it the same way. So we can put this one in. I should put a red one in here. So where's a red one? Right here. Okay, so this isn't where it needs to be. I can turn it over here. Okay, this will come to here. Now let's move this to where there's a green center. There's a green center here. It doesn't matter which direction it goes. There's no specificity. So this will go real fast. Move it up, down, down, up, up, and move this back. It gets your centers back and reduces this and starts to reduce this. Now before, to move these in, I would have to do a lot of that 3 cycle, but that 3 cycle is now done. So I want to move this in. We'll move this green down to here and then to here to move this in position here. Here's a blue one, so we can easily move this to any of these blue spots. Down, 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 up, up, and up. Boom. Let's finish the blue. Move this to here. This blue will come here. This yellow will go to the yellow here. Up, down, down, up, up, and back. Okay, kind of got lost there just for a second. Okay, so I could put this in, but that's going to render these 2 not done. So let's start moving these guys in. Okay, I want to move an orange one in here, so this will go here. Let's move the white one in here. So let's start on it. Down, 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 up, up, and back. Okay, now I have these 3 to go. So here's a yellow. Let's move a yellow one in. Right here, this to here. Let's find my orange. Oop, and the orange is right here. Is this where we want it? Nope, got to turn this upside down. So let's move this to here twice and move it back from this angle, and now this should do it. Down, 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 up, up, and move it back. Boom. And so there you have it. All the edges and centers are now reduced, and because there's no parity, you'll see just how straightforward this next part is. So first part, move your corners in. So where's the other green corner? It's right over here. So I'm simply going to move this like so. So in, and move this corner in over here. Boom. So this represents one side. Forget about this. This is the center. I'm just going to move the edges in, down from this side over here. This red one is already in. I need the green one. Here's the green one. So I'm going to move this corner down, move this edge in, move the corner up. So that's good. Now I'm looking for the white one. It's right over here. Move to the side, corner down, edge in, move it up. Okay, so this side is done. Turn this upside down, and all the edges are in. Most of the time it's going to be that way. If not, then you might have two that are flip-flopped, or you might have all of them that are rotated. If that happens, R, U, R, I, U, R, U, R, I. Okay, so if after solving this part here, you look at this, you see these aren't in. If they're not all in, then you just do the SUNY to sort of rotate them. So starting over here, bringing this edge up, you do R, U, R, I, U, R, U, R, I. Take a look. If it's not there yet, do it again. R, U, R, I, U, R, U, R, I. Okay, now most of the time it's going to be like this because honestly, if these were upside down, you wouldn't know it. They might be upside down as we speak, but you wouldn't know it because there's equivalency. And you're not going to get a situation where something needs to be flipped wrong because, well, it's just not going to happen that way. These centers guided you where it's supposed to be. In this case, and in this case, whoops. In this case, you didn't have central edges that guided you. Okay, fair enough. So now that we've done that, all these are in, we just have to move the centers in, and I know that they're either where they need to be or they just need to be flip-flopped. So here's green. This is green, white, and red. That belongs here, and these two obviously need to be flip-flopped. So flip-flop them 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, and 3. Okay, so this is in and this is in. These are also in, but they're rotated wrong. So, you know, I'm swapping these centers the same way that we did with this puzzle here. You can see that this is rotated incorrectly. This has to be rotated clockwise, so go ahead and do that. Turn this side clockwise, like so, boom. Now swap them, turn it back, and swap it back. So to swap these two corners, we go 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, and 3. Now swap it back. Let's say you don't remember which way you turned it. Doesn't matter. Just match the same edge with this corner. So it's over here. You see it's matched. And now we swap them again. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, and 3, and done! Your master Skewb is now solved, and that's a solve just like a tetrahedron. It's got a lot of appeal to it because I didn't have to do all those 3 cycles all around the puzzle with this part and this part. I only had to do that a few times between just 2 areas, which only took a couple of those algorithms to do. So give it a try, and I'll leave it to you if that's how you want to solve it from now on, because you can start doing higher order Skewbs just the same way by reduction of centers and reduction of edges, and solving it like that as well. So we're getting into the home stretch as we put this in the place of where it's supposed to be, with this correlative with this Skewb over here, and the tetrahedra that it's correlative with is this guy. Oh, actually not this guy, that's an even higher order version of it. It's actually this guy over here. So this belongs as the tetrahedral version over here. And remember what we're defining this. This is the base of your platonic tetrahedral twisty puzzle solid, as it has all the characteristics that we talked about. Being a platonic solid, being a face turner, being the base puzzle to which all others are reduced to, and also having no trivial pieces. All pieces are the same. Tetrahedral versions are basically a truncated version, a rectified truncated version that went all the way down to another platonic solid from a twisty puzzle point of view, and these are the cubic transformations of all of those. So this that we now know that the F-Skewb is in between the Skewb and the master Skewb. So we know that it is completely in line with that if you look at it as a modification of a twisty puzzle. Next, we're going to move into this territory. And my question is, in this 1, 2, 3, 4, 5, 6, 7 layer tetrahedron, is there a cubic version of this, just like we saw with the F-Skewb? And what would the tetrahedral version, or what would the octahedral version of this look like if one such exists? So next we'll tackle this and see what happens. Thanks for watching.